Master-slave architecture in distributed systems with OWS and SageMaker. Definition: Master-slave architecture is a distributed computing model where one node, the master, controls and coordinates the activities of other nodes' slaves to perform tasks efficiently, ensuring parallel processing, fault tolerance, and scalability for large language models (LLM) and retrieval augmented generation (RAG) projects. Leveraging AWS, Amazon Web Services, and SageMaker. Key components: AWS services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Integrated with AWS services for master-slave configurations in distributed computing. EC2, Elastic Compute Cloud instances that can be configured as master or slave nodes to perform distributed tasks and processing. RDS, Relational Database Service for managing SQL databases, supporting master-slave replication for data consistency and availability. S3, Object Storage Service for storing and accessing data across distributed nodes, facilitating data sharing and coordination in master-slave setups. CloudFormation, Infrastructure as Code IaaC tool for provisioning and managing AWS resources, ensuring consistency in master-slave configurations. Master-slave techniques. Task distribution assigns tasks and workload distribution from the master node to multiple slave nodes for parallel processing and improved performance. Data replication replicates data from the master node to slave nodes to ensure data availability, consistency, and fault tolerance in distributed environments. Coordination and synchronization manages communication and synchronization between master and slave nodes to maintain data integrity and task coherence. Scalability management scales slave nodes dynamically based on workload demands, optimizing resource usage and system performance in distributed setups. Benefits: parallel processing improves processing speed and efficiency by distributing tasks across multiple slave nodes. Leveraging parallel computing capabilities. Fault tolerance enhances system reliability and availability by replicating data and workload across multiple slave nodes, minimizing single points of failure. Scalability scales system capacity horizontally by adding or removing slave nodes dynamically to handle increasing workload demands in distributed deployments. Data consistency ensures data consistency and integrity by replicating and synchronizing data updates between master and slave nodes in real time. Cost effectiveness optimizes resource utilization and operational costs by scaling slave nodes based on actual workload demands and system requirements. Tools and technologies. AWS EC2, Elastic Compute Cloud instances for configuring master and slave nodes to perform distributed computing tasks and processing. AWS RDS, Relational Database Service with master-slave replication capabilities for managing SQL databases and ensuring data consistency in distributed setups. AWS S3, Object Storage Service with built-in capabilities for storing and accessing data across distributed nodes, supporting data sharing in master-slave architectures. AWS CloudFormation, Infrastructure as Code IaaC tool for automating provisioning and management of AWS resources, ensuring consistency in master-slave configurations. AWS CLI, Command Line Interface tool for efficient management and configuration of AWS resources and services, including master-slave setups. Challenges: data synchronization, managing synchronization delays and ensuring real-time data consistency between master and slave Nodes in distributed computing environments. Scalability design. Designing scalable master-slave architectures that can dynamically adjust to varying workload demands and operational requirements. Performance tuning. Fine-tuning master-slave configurations and workload distribution strategies to optimize system performance and resource utilization. Fault tolerance strategies. Implementing robust fault tolerance mechanisms to handle node failures and maintain system reliability in distributed deployments. Security and access control. Ensuring secure communication and access control between master and slave nodes to protect data integrity and prevent unauthorized access.